Okay, find the length of each arc. So today we're looking at arc length and sector area. And if we recall, arc length, or an arc, is a small section of the circumference. So it's a distance. And so we will be using the circumference formula when we're talking about arc length. Sorry about that. I've already circumference, spelled that wrong. Circumference formula, and the sector of a circle is a part of a circle, okay, and it's a part of a circle that's formed by two radii and the circumference. Okay, so it's a part of the entire area of a circle, and so because it's a part of the area of a circle, we're using the area formula. So circumference, if we recall, is 2 times pi times r, and the area, again, is pi r squared. Okay, so another thing that we need to think about is the total, if we're looking at a circle, and we've got a circle, the distance, or we know the measure from this point to this point, this is going to be a 90 degree, and this is 90 degrees, and this down here is 90 degrees, and this here is 90 degrees. And so the total degrees of a circle is 360 degrees. So that's the entire circle is 360 degrees. And so we're going to be using portions of this. And so we know that the total is always 360, which really enables us to figure out what parts are equal to. Okay, so if we are looking for the arc length of this arc right here, so we're looking for the arc length of this down here. We're not looking for the entire circumference, we're just looking for a part of it, and we're looking for the part of it that 210 degrees of it makes, right? And so we're going to be using the circumference formula, but we're going to be using just a fraction in the front of it. And what we know is a total all the way around is 360 degrees, but we're only going 210 degrees around. So we have 210 divided by 360 times 2 times pi times the radius of 15 kilometers. Okay, so that's the only difference now. Our arc length is equal to a portion of the circumference, and the portion of the circumference that it's equal to is the degree of the arc, the degree of that angle, divided by 360 degrees, and then using the rest of the formula. So we have 210 divided by 360 times 2 times pi times 15. And again, let's just leave it in actual, let's not convert it to, okay, we're leaving it as exact answers. So if we leave it as exact answers, we would find that the arc length is 35 halves pi kilometers, or 17.5 pi kilometers. So that would be the arc length of this particular arc. Okay, let's look at question 3 here. We're given that we're looking for the arc length, and our angle is 270 degrees. And so what we know is we're going to say 270 degrees divided by 360, that's the portion we're looking for, times 2 times pi times 9 kilometers. Okay, so we've got 270 divided by 360, which reduces down to 3/4, times 2 times 9 times pi. So we have 3/4 times 2 times 9 is 27 halves pi, which would be 13.5 pi kilometers, because we still need these units. If we're looking for the angle of each sector, we're doing the exact same thing. We are just, instead of using the circumference formula, we're using the area formula. Okay, so this angle here is 225 degrees, and what we're looking for is this area right here, all of this. So that's what we're trying to find. And so we're using the area formula, but we're not looking for the entire area of the circle, we're just looking for a portion of it. And so we've got that area is equal to pi r squared, right? And so we're not looking for the entire area though, we're looking for what is 225 divided by 360, this portion of the area, times pi times 12 yards squared. So we've got 225 divided by 360 times 12 squared is 90. So this would be 90 pi yards squared. And we can leave it exactly as that answer. Okay, what about question number 7? Okay, so in 7, again, we are looking for this area right here, all of this. So we're not looking for the entire 360 degrees. We're looking for what is 315 degrees divided by 360, so that portion of the area of this circle. So we've got 315 divided by 360 times pi times 12 inches squared. So 315 divided by 360 times 12 squared is equal to 126 pi inches squared. So that would be the answer here. And you can leave it like that. So that is what we're doing for finding the length of each arc and finding the area of each sector. So again, you're just using the circumference and the area formulas, but because we're not looking for the entire 360 degrees, we've got to use that angle in the middle. And so we call that angle a central angle, and we want to know, okay, what is that area? What is that area that's formed? So we're using the central angle, 225 here divided by 360. That's going to give us this particular portion, and that's what we're looking for.